Hello, everyone. So today I'm just a disembodied voice, but don't let that distract you. Now you just don't have to look at me. But in this video, we are going to talk about evaluating the output of a function machine from a given input. And then we're going to talk about this thing called function notation. So let's see, input and output, that might be some new vocab. And function notation, I think, is new to most of us. So when I say function machine, this is just a tool that I like to use to kind of visualize what something is doing. So I'm going to draw a little function machine. This is how I draw it. It's just a rectangle. You throw stuff in the top, and then it spits stuff out the bottom. Okay, so the stuff that goes in, we call that the input. Just like how the input on your phone, say, is you push the buttons. And when you dial someone's phone number, then the output, the thing that it produces, is the call that goes to the other person. But the input is also often called the independent variable. You might have heard that term before, and it makes more sense once we hear what the other thing is called. And that's usually denoted x. The thing that comes out is, of course, the output then, often called the dependent variable. And the reason it's called the dependent variable is because, well, it depends, the thing that comes out depends on what went in. And again, that's usually used, we usually use y to reference that. And so let's pretend that my function machine in this case is the function machine y equals x squared minus 1. Alrighty, so what we're going to do is just see what happens when I input something. So let's pretend I put in x equals 5. Alrighty, so the way the function machine works is there's kind of little gears and bits and bobs and conveyor belts and such inside the function machine. Or maybe you could think of it as little gremlins or elves inside of it. But they're just kind of hanging out, and then in drops this 5. So they see that and like, ooh, okay. So the input is x. Remember, that's our independent variable. And so wherever there's an x, you replace it with a 5. And so now this says, hey, 5 squared minus 1. Okay, and just remember to correctly do order of operations. This will say 25 minus 1, which is 24. And this is what goes out. The little elves inside, they push the 24 out. And so the output is y equals 24. Alrighty, let's do another one. So I'll make another function machine here. And in this one, I'm going to say y equals, how about 3x over x minus 5. Okay, so we'll do the same input. We're still going to throw in 5. So let's put in x equals 5 and throw it in there. Now remember, you have to use that x equals 5 to replace all the x's. So in this case, we see that in 2 places. Oops, sorry about that. We see the x on top times 3 and on the bottom in the x minus 5. So let's make sure we correctly plug that in. That's going to say, okay, I have 3 times 5 on top. On the bottom, I have 5 minus 5. I'm going to go up here, I realized I didn't make it very tall. Now our equation, our function machine says 15 divided by 0. And so what comes out is, wait a minute, 15 divided by 0, that's, if you remember, we can't quite do that. This would be undefined. Undefined, we'll say. And so that's basically what's going to come out, because there is no number for 15 divided by 0. Undefined or error. So this is why if you, in your calculator, if you did 15 divided by 0, it says error. You might say domain error. So when we plug in, this is an interesting one. In this function machine, you can't give it 5. Because if you give it 5, it's going to make you divide by, the function machine is going to try to divide by 0, and the elves refuse to do it inside that function machine. And so it sputters out of control, and there's smoke everywhere, and so on. Right? It breaks it if you plug in x equals 5. So that's definitely a possibility when you're plugging numbers into your function machine. Okay. So the things to be careful of. 1, make sure, so let's actually, maybe we should write this down. when evaluating outputs of function machines, two things to be careful of function machines. And I should just say this, I've thrown the word function around a lot, obviously, in this video. Function has a very, very specific term or meaning in math, and we're going to get to this in a future video. So right now, just kind of roll with me. When evaluating outputs of function machines, one, be very, very careful with your order of operations. With your order of operations. So remember, a function machine it knows what to do. The elves inside are pretty good at math, and so if you plug in x equals 5 and I plug in x equals 5, we should get the same thing. And if we don't have that order of operations, if we don't agree on that, then we're gonna get different outputs, but we should get the same thing. So just be really, really careful of that order of operations. And the second thing to be careful of, and this is going back to what we did in the previous one, where this one had x in two places. We want to be really, really careful to make sure to replace the input in all the right places. To replace x, or the input, in all places, I'll say. That made more sense in my head. But just make sure you replace all the x's with 5 in that previous example. Okay, so just be really careful there. Okay, I'm gonna redraw that first function machine here, and you will see why. So this is getting to this function notation bit. Function notation. Okay, so we saw here that in the function machine y equals x squared minus 1, I'm not going to go through all the work again, but when I threw in x equals 5, I'll do that in red actually. When we threw in x equals 5 as an input, the output that came out was y equals 24, right? Okay, so in English, what we could say is when you plug I'll say input, sorry. When you input x equals 5 into y equals x squared minus 1, the output is y equals 24. Okay, that's kind of a long sentence. Alrighty, here's a faster way to say it that mathematicians have kind of figured out. What I'm going to do is I'm going to just replace, instead of saying y equals x squared minus 1, I'm going to say this thing f parentheses x equals x squared minus 1. Bear with me. Okay, so the same thing happens here. You still input, oopsies, x equals 5. Pretend we still put that in there. And the output is still 24, right? Because it's the same rule. So we're essentially just turning that y into this f parentheses x thing. Alrighty. The way we write this is the output, instead of saying y now, we're going to say the output is f parentheses 5 equals 24. And all this means is that you took the original function, or the original rule. Again, the rule is basically the guts of the function machine. It determines what it does to the x. It essentially says this, the exact same thing. So the way we would say it is f of x equals x squared minus 1. This is the rule or of the equation. And we would say f of 5 equals 24. This green sentence and this green 2 lines say the exact same thing. in words, f parentheses x is, we say f of x. And I write them out because, just so you know that I'm like, it's literally what comes out of your mouth. And so if I said f of 5 equals 24, this would translate in English to f of 5 is or equals 24. Okay, so really all you're saying is, well, mathematically what you're doing is you're just replacing y, or the output, with that f parentheses x thing. Again, this on its own, this red part right here, is just a shorter way of saying this right here. So the output, when you input 5, out comes 24. So why don't you take a second and practice on, if this is the same f of x, same function machine, what is f of 3? So I want you to pause the video here and try that one on your own. Alrighty, so if you've tried it, then all this says is basically replace x with 3. And so now f of 3 says, well, actually it might help to draw them on top of each other. F of x equals x squared minus 1. And I'm going to highlight the x's. So there's x there, there's x there. And so now if it says f of 3, that is right here, so it should just say 3 squared minus 1. And that's just going to be 9 minus 1, which is 8. And so the way we would write that, instead of saying, hey, when I plugged in 3, I got 8, all I have to say is f of 3 is equal to 8. That's all we have to say. So there's a lot more that we can do with this, but just before we leave, I just want to talk about the use of this. And the reason this is helpful, there's multiple ways, but the reason I find it most helpful is because sometimes you're working with more than one function machine at a time, and it's just a helpful way to differentiate which one you're talking about. So I might have 2 function machines here. So maybe this one is y equals x squared minus 1. And then over here, I could say y equals whatever the other example was, 3x over x plus 3, say. So if I just said, what is the output when you input x equals 15, pretend 15. Well, if I just said that, you have no idea what function I want, which function machine I'm asking about, right? So that's a problem. But if I said, hey, this one on the left, that is f of x, and it's one on the right, call it g of x, first off, there's no reason it has to be f. We usually use f first because it's function, but it doesn't have to be f. It could be f, it could be g, it could be h. It's usually the way it goes. It starts with f and then you just go on when you need more. So now, because I know I give them different names, now I actually can easily tell you which one to plug in. So if I ask for now, oh, okay, what is g of 15? You know right away, oh, I'm supposed to plug in 15 into this one right here. And out comes whatever this is, 3 times 15 over 15 plus 3. Right? I think that would be 45 over 18, which would come out to, if I divide top and bottom by 9, I'll get 5 halves. Alrighty. And so that would be g of 15. Okay, so hopefully this wasn't too tricky. I think at the beginning, you might have had already a pretty good hold on that, but I do think function notation throws people off, at least at first. Alrighty, so I'll catch you all in the next video. Thanks for watching.